Let's rewind. Way back, before cities, before fire, before even brains as we know them today, life began in water, and for millions of years it stayed there. But then came one of the greatest plot twists in Earth's history, the water to land evolution. Some adventurous, fish like creatures started crawling onto land. Over generations, they developed lungs, limbs, and eventually the ability to survive and thrive on solid ground. This was a major breakthrough, and from this land dwelling lineage came a game changer. Mammals with a neocortex. Now, the neocortex is the part of the brain that lets us think, learn, and adapt. And it gave mammals an edge, better senses, flexible behaviors. It's like nature's upgrade chip for intelligence. And this upgrade set the stage for everything that came next. Our story continues in East Africa. Around 4 million years ago, the earth was changing. Forests gave way to open savannas, and out of the trees stepped one of our earliest ancestors, Australopithecus. These apes were different. They weren't just climbing, they were walking upright. This shift, known as bipedalism, marks the second major breakthrough. It freed up their hands for carrying food, babies, using sticks to dig up roots, waving off predators, and most importantly, tool use. Fast forward to Homo habilis, the handyman, around 2.6 million years ago. This is where we see the first real tools, sharp stone flakes chipped from larger rocks. These tools were used to cut meat, scrape hides, break open bones for nutrient-rich marrow. With hands liberated and brains growing, early humans started to shape the world around them. At this point, they weren't just animals reacting to environment. They were engineering their survival. Each new generation learned and improved. Now imagine this. This was 300,000 years ago. That's when our own species, Homo sapiens, entered the scene. At first, we were not so different from our human cousins. But over time, something remarkable began to unfold. We gradually developed language, not just grunts or gestures, but complex symbolic communication. Picture a group gathered around a fire. They are starting to share stories, plan hunts, teach skills, not just with actions, but with words. This was the third major breakthrough, and it changed everything. You see, we weren't the only humans around. There were Neanderthals, Denisovans, even Homo floresiensis, all capable intelligent species. But Homo sapiens had something that they didn't master in the same way: language. It allowed us to pass down knowledge, ideas, warnings, not just through generations but across entire tribes. With language, we could collaborate, strategize, and coordinate attacks, and that made us unstoppable. Language helped us to outsmart, outcompete, and eventually outlast every other human species. Once we had mastered language, something astonishing happened. We stopped wandering. Around 12,000 years ago, humans discovered the power of agriculture. Instead of chasing food, we grew it. We domesticated plants and animals, and the moment we did that, the seeds for civilization were planted. With steady food came population growth. From Mesopotamia to the Indus Valley, from Nile to the Yangtze, cultures blossomed independently. And with every innovation, we became more powerful, more connected, more intelligent, not just individually, but as a species. Around 250 years ago, humanity hit another turning point, the Industrial Revolution. It started with steam engines and spinning machines, but it rewired our entire planet. We discovered fossil fuels and built machines that replaced muscle. We moved from villages to megacities, from hand tools to automated factories. And with that came a massive leap in production, learning, and information sharing. Knowledge wasn't just passed by word of mouth anymore. We had books, newspapers, telegraphs, and soon radios. The rate at which humans could store, share, and apply knowledge exploded. In just a few generations, we began reshaping every inch of earth and our own minds along with it. And then we went even further. We split the atom, we mapped the genome, we left the planet. Think about it. In just 12,000 years, a blink in evolutionary time, we went from hunting deer with spears to hunting black holes with telescopes. We became the apex predator of the entire planet, not because of our strength, but because of our minds, because of our ability to build on what came before. In the middle of World War II, one man asked a question that would change the future. Can machines think? Alan Turing, British mathematician, codebreaker, and father of computer science. It wasn't just a thought experiment. Turing helped build one of the first computers, a machine to break Nazi codes. But he dreamed even bigger. What if someday machines could learn, could solve problems, could show signs of intelligence? That question laid the foundation for what we now call artificial intelligence. Just a few years later, scientists built the first model of neural network, an attempt to mimic how neurons in the human brain fire and connect. It was primitive, but it planted the seed. Over time, machines got faster, data got bigger, and AI began to emerge. Today, narrow AI is everywhere. Google Maps finds the fastest route through traffic. Instagram's algorithm knows what you like before you do. Your iPhone unlocks just by recognizing your face. But here is the catch. These AIs are specialists. They are trained on huge data sets, but they operate within very narrow boundaries. Google Maps can't play a chess. Instagram can't drive a car. Face ID can't write a novel. Each system is a tool, brilliant at one task but clueless outside its domain. This is called narrow artificial intelligence. While it is impressive, it is also limited. It's not curious, it's not truly thinking, it doesn't understand why behind the what. And yet, this narrow intelligence is the foundation for what comes next. Because now we are aiming higher. We are trying to build machines that aren't just trained to do one thing, but machines that can learn anything, that can reason, adapt, and grow on their own. If you ask a child to solve a math problem, then draw a cat, then understand a joke, she can do all three. Maybe not perfectly, but with context, creativity, and adaptability. That's because humans don't just specialize, we generalize. We connect the dots across domains. We reason, we imagine, and most importantly, we learn from just a few examples. This ability is called general intelligence, the kind of thinking that lets you switch from fixing a bike to cooking dinner to comforting a friend without needing to be retrained for each task. And that's what scientists and engineers are now trying to replicate in machines. Artificial General Intelligence, AGI. It's not another feature or an app. It's the next frontier of intelligence. Think about it. We humans took millions of years to evolve our brains. It took Homo sapiens 300,000 years to figure out fire, farming, and Facebook. But an AGI, it could learn everything we know and then improve itself. Not over centuries, but possibly in days or in hours. It could read every book ever written, master every subject, and discover patterns no human mind could ever see. Imagine an intelligence that combines the brilliance of Einstein, Newton, Da Vinci, Shakespeare, and Beethoven, and then evolves exponentially through version 2.0, 3.0, 4.0, all the way to 100.0. AI has already achieved superhuman intelligence in specific domains. For example, AI programs have defeated world champions in complex games like chess, Go, StarCraft, showcasing their ability to master intricate strategies and outperform the best human minds. Now imagine that level of outperformance not just in games, but in everything. Medicine, physics, climate science, economics, creativity, negotiation, decision making, even understanding you better than you understand yourself. That's what makes AGI different. It's a thinking entity, and one that keeps getting smarter. We have made fire, we have made tools, we have made rockets, satellites, smartphones, but this is the first time in all of human history we are creating something smarter than ourselves. It doesn't need sleep, it doesn't forget, it can juggle 10,000 ideas at once across every domain. It can learn a new language in seconds and run a million simulations before your next breath, spot patterns in data that even greatest minds alive wouldn't notice in their lifetime. Okay, human intelligence is amazing, but it's biological, it's slow, it's limited. It's limited by neurons, energy, and memory. We still don't fully understand black holes, those cosmic monsters that bend space and time. We still haven't figured out how life began on Earth. We are still baffled by how the ancient pyramids were built with such precision thousands of years ago. There are unsolved theorems in mathematics that have eluded the greatest minds for centuries. And quantum physics, even experts admit, if you think you understand it, you don't. This is where AGI changes the game. It's digital, It's lightning fast. It doesn't suffer cognitive fatigue like us. It can copy itself, improve itself, and test billions of ideas in minutes, capable of running simulations millions of times faster than any lab on Earth. Suddenly, the origin of universe might not be a mystery. New medicines could be discovered in hours, not years. We might decode the brain, fix mental illness, reverse aging, build clean energy solutions we never dreamed of, create entirely new branches of science. For all of human history, we have been the smartest species on the planet. We made the rules, we shaped the earth, we created machines, empires, and ideas that could outlast us. Now we are facing the creation of not just faster calculators or clever code, but true intelligence that can think, reason, plan, and create at levels we can't even fathom. Frankly, we have never been in this position before. It's not like inventing fire or inventing electricity. It's like giving birth to a new kind of mind. But here is the catch. To build something like that, we need to do more than just increase computing power. We need to understand how our brain works, because the best blueprint we have for general intelligence is the human brain. But the human brain is still very complicated and mysterious. We know the basics, what neurons and neurotransmitters do, and where the main parts of the brain are, but we still don't fully understand how the brain works, especially when it comes to complex things like thinking and decision making. And it's crucial to emphasize that there is no universally accepted definition of AGI, and we don't know when or even if we will create it. Some say AGI is around the corner, and others believe it will take decades, and a few argue it might never happen at all. You have got CEOs from OpenAI and Anthropic saying we might hit AGI before 2030. Demis Hassabis, the CEO of Google DeepMind, says within a decade. But not everyone is convinced. Yen Luquan, Meta's chief AI scientist and one of the godfathers of deep learning, has a different take. He says, look, current AI systems can pass law exams, solve math problems, but they can't unload a dishwasher. He argues we are still nowhere close to duplicating something as simple as a cat's brain, let alone true human level cognition. So, what is the debate really about? It often comes down to LLMs, large language models like ChatGPT, Gemini, Claude, DeepSeek. LLMs are trained to predict the next word in a sentence. They have read everything: books, websites, research papers, and from that, they have learned to sound incredibly intelligent. Some say they are not truly intelligent, they are just very advanced parrots. And then there is the speculation. Some people in the tech world believe AGI might already exist behind closed doors, that the top AI companies are keeping it under wraps, testing it carefully, making sure it doesn't pose a danger to humanity. We don't know if that is true, but here is what we do know. In the past few weeks alone, we have witnessed something that sounds like science fiction. We edited a human, a 9-month-old baby born with a deadly genetic condition, had his DNA rewritten, precisely, safely. In science labs, AI is discovering new materials, from next-gen batteries to futuristic superconductors. What once took years of trial and error now happens in days, thanks to AI models that simulate chemical reactions and suggest entirely novel compounds. In medicine, AI is accelerating drug discovery at an unprecedented pace, identifying promising treatments in weeks instead of years. It's also diagnosing cancers with remarkable accuracy, sometimes even outperforming seasoned doctors, and doing it faster than ever before. AI also helps surgeons perform delicate procedures with superhuman precision. It detects wildfires before they spread, and it's decoding the language of animals, potentially bridging communication across species. Meanwhile, humanoid robots are stepping out of science fiction and into real factories. With human-like agility, they walk, lift, and perform intricate tasks once limited to trained workers. They are not just tools, they are collaborators, and they are only getting better. Self-driving cars navigate complex traffic with superhuman reflexes. And then there are digital employees, agentic AIs that browse the internet, book appointments, handle customer support, generate reports, and even negotiate deals, all without human micromanagement. You give them a goal and they go to work. It's like outsourcing parts of your brain. Generative AI has taken creativity to a whole new level, producing ultra photorealistic images, entire videos, high quality music, and even working software, all from a simple prompt. Just tell it what you want and it builds it. With every passing week, AI is rewriting the rules of medicine, science, creativity, and work itself. And now AI is helping us bridge the gap between thought and action. Brain computer interfaces like Neuralink are enabling people with paralysis to control computers. Another, paralyzed from the shoulders down, is editing videos and browsing the web using only his mind. Remember AlphaFold? That AI cracked the structure of 200 million proteins, a task so monumental it would have taken scientists a billion years. Now, that same spirit of discovery is being scaled across every field: medicine, energy, education, climate, space. For millions of years, evolution moved at the pace of nature. Then came humans. Suddenly, ideas could outlive generations. Now, intelligence is evolving faster than ever. The next chapter of intelligence on Earth has begun, and we all have a role in writing it. The limit is not what machines can do, but what we dare to imagine.